Hi, my name is Brittany Boribong. I am a postdoc with LaSalle Yonker, and today I'm going to be talking about my research, which involves looking at neutrophil inflammation in pediatric COVID-19 and the condition multisystem inflammatory syndrome in children. So this condition is also called MGHfC, and it occurs 4 to 6 weeks post-COVID infection or exposure and happens specifically within children. This condition results in inflammation that can affect multiple organs and can lead to severe symptoms within these patients. Comparing MGHfC with pediatric COVID-19, you can look in this heat map that children with COVID-19 have very minimal symptoms and also experience a low mortality rate. However, children with MGHfC have a higher mortality rate and also experience more severe symptoms such as fever, rash, cardiac complications, and gastrointestinal issues. So we want to understand, why is there such a vast difference in immune response in children with COVID-19 versus children with MGHfC? And to look into this, we wanted to focus specifically on the innate immune system, and specifically within that, the neutrophils, which are the most abundant white blood cell within the innate immune system, as well as the first responders of an infection, meaning they play a pivotal role in the initial inflammatory response to an infection and a pathogen. And so we wanted to study the role of neutrophils within COVID-19 and MGHfC in pediatric patients. And so to do so, we looked at both the gene expression of neutrophils as well as looking at functional neutrophil assays. So first, we collected neutrophils from a group of healthy children, a group of children with COVID-19, and a group of children with MGHfC. And we first looked at the neutrophil gene expression in pediatric COVID-19. And here we can see that neutrophils from COVID-19 patients had an upregulation in pathways and genes involved in the interferon response. So this leads to patients with COVID-19, their neutrophils are immediately responding to the SARS-CoV-2 virus and able to clear up the pathogen and virus before it's able to inflict too much damage within the system. However, patients with MGHfC, their neutrophils show an upregulation in pathways and genes that are involved in neutrophil activation, neutrophil degranulation, and ROS production. So this is showing that the neutrophils are highly activated and inflammatory. And these specific genes and pathways can also lead to an upregulation of the release of neutrophil extracellular traps, or NETs, which is a highly inflammatory response of a neutrophil toward a pathogen. And so we wanted to understand, what is the difference in NET release between healthy patients and patients with MGHfC, since we saw this highly upregulated gene expression in these MGHfC patients. So we first looked at NETs in healthy patients, where these are neutrophils isolated from these healthy patients and not stimulated with anything. And so you can see here on the right, these are neutrophils that are just simply dying off and not releasing any NETs. So they're not very inflammatory. However, neutrophils from MGHfC patients, as you can see in the movie, there's kind of this blurry outline. So these are neutrophils that are releasing their DNA and releasing these extracellular traps and releasing high amounts of inflammation within the system. So this can lead us to helping us understand the amount of inflammation that is in these patients with MGHfC. And so in conclusion, the differences in neutrophil gene expression in pediatric COVID-19 and MGHfC can help explain the difference in severity and its immune response. And specifically, neutrophils within MGHfC patients are highly activated, which can be shown in the gene expression and the spontaneous release of NETs, which can lead to high inflammation within the system. And so these activated neutrophils may contribute to the systemic inflammation found within these MGHfC patients. Here are my acknowledgements, and I'd like to thank you for listening to my presentation.